Hey everyone, welcome to the next video series, and we are going to be talking about linear relations this time around, continuing from where we left off with linear solutions. What you're going to be doing in these videos, first I'm going to introduce you to the idea of linear relationships. We're going to talk about how to describe a graph, what it means, and then we're going to get into the bullet points down here where it's recognizing patterns, analyzing data from a table of values. You're going to be graphing two variable linear equations, so just x and y, straight lines, and you are going to be solving problems using linear relationships. All right, so we're going to get into just this time around talking about what this stuff all means and how we can describe these linear relationships. Okay, first off, the kind of questions you're going to be able to, or you're going to have to ask yourself and be able to describe are whether there are relationships shown between an x and y axis graph. So here you see one on the left, it has just dots. And this one has a straight line going in both directions, and it's got an upward slope. So we can see that there are some relationships between these things. Yes, definitely a line has something to do with the x and y axis, and even these dots here, you can tell that, if I connect the dots here, and I connected these with a straight line, that's not quite following. Close, there, better, getting closer. If I did connect those dots, they do have a relationship that is pretty much like a straight line. I'm going to get this someday. Oh, come on. There we go. That's a better one. So there is a relationship that we should be able to talk about. All right. Here are the four ways that we are going to be describing a graph. The first way is, what does the graph relate to? What are we actually talking about? For example, in a science experiment, the temperature would change with the amount of time that it's being heated. And we could have one of those variables be along the x-axis, and one of the other one be going along the y. We probably have time on the bottom because we'd count it like 0 minutes, 1 minute, 2 minutes, 3 minutes, and then the temperature as it rises or as it falls or whatever we're doing, it would change. And in that way, we would say that the temperature is relating to the amount of time. So the y-axis is relating to the x-axis. The second thing that we're going to talk about is, where does it start? Where is the first point, the first ordered pair on the graph? Like, where's the beginning? And that's not always the case. If we have a line that goes all the way through the graph, there might not be a first initial point that we have, but we could at least tell what quadrants we would find it in. Where does it start? Where does it end? What does it cross through? That sort of thing. The third piece, how does it change? And by change, I mean rise and run. You should remember that from the past. Rise over run. We're talking about the slope here. How much does it go up for each step that it goes to the right? So that's going to be important. The direction, up or down of the graph, you read it from left to right. So you have your Cartesian plane here. You're always reading it left to right, and we're reading it up or down. Well, we're looking at it like going up and in that direction. So a positive slope would look like this, what I just drew here. That's positive slope. And we're looking at it going upwards and to the right. That is one crazy mess I just drew there. The last piece, if it is continuous or discrete. I'm going to say what those things mean, and then I'm going to kind of explain them a little bit better. Discrete data can only have exact values. Continuous data can have any value. So discrete data, to break it down to something simpler, let's say you're ordering a pizza and you call in, you're ordering, in the next slide we're going to talk about a medium pizza with toppings. You get to choose how many toppings. You are probably going to say, well, I'm going to choose a 3-topping pizza. You will probably not say, I'm going to choose a 3.727 toppings pizza, because that wouldn't make a whole lot of sense. And that's how we know it's discrete data. it has to be exact values. It has to be 1 topping or 2 toppings or 3 toppings or 4 toppings. It can't be some really wacky number. Continuous data can. Continuous data can have those wacky decimals. Things like comparing distance to time. How far can you get in a car going at this speed? Well, it's not always going to be an exact number. It's going to be continuous data. All right, moving forward. So let's get into the nitty-gritty of this stuff. We have an example here about Tony's Pizzeria, and I alluded to this already. We're going to talk about pizza a few times here. I could go for a pizza right now. I'm kind of shut in right now, but we have a medium pizza that is $9, and each extra topping for your pizza is $1. You start off with a 0 topping pizza. I guess it's just cheese. So if you wanted to purchase something that was 2 toppings, you should be able to do this in your head pretty easily. And just take a second now, think about this. How much would a medium pizza with 2 toppings cost? You probably said $11. I'd be surprised if you got that one wrong. And you probably did it like this. Well, I know it's $9, definitely. And then 2 toppings, and each topping is $1, so that's an extra $2. $1 plus $1 is $2, so that's $11. Great. All right. We could have also set this up as a linear relationship. So we could say it's, $9, the cost of my pizza. I'm going to write cost of pizza. So my cost is $9 plus $1 times my toppings. And that's a linear relationship here. So no matter what I choose, if it's 1 topping, then it's 9 plus 1 times 1 is 1, $10. Makes sense. Or 9 plus 1 times 2 toppings is $2, $11 total. And so it has that relationship. Every topping that you add, it increases it by 1. And that's what we're going to see in the graph right here. So for every topping that we add, the cost of the pizza goes up 1. All right, looking at this, we have the pizza graph. What does the graph relate to? This stuff you don't have to answer yet. I'm going to give this as a model, but in the future ones, I want you to think about these questions, pause the video first, and then go through it and see if your answer matches up to mine. Okay, what does the graph relate to? Well, on the left here, I have costs, and it's comparing the cost of the pizza to the number of toppings that I've chosen. So the cost, the y-axis, this one, relates to the number of toppings along the x-axis. Where does the graph start? In this case, it's very simple. It starts at a 0 topping pizza, which is just cheese, I guess, and it's $9. So it starts at 0.9 right here. And I could also say that the points are all in quadrant 1. How does the graph change? Well, for every 1 step up, there is also 1 step to the right. For every 1 step up, the point moves 1 step up. What did I write there? What I'm trying to say is for every 1 step up, I go 1 step to the right. 1 step up, 1 step to the right. 1 step up, 1 step to the right. My rise is 1 and my run is 1. Rise is up, run, 1. Rise, run, rise, run, rise, run. Okay? And there's something else down here. Let's see what it says. The graph is going up. And the graph is going up means it is positive. It's a positive slope. Okay. Now, the last question of the day here, not of the day really, the last question is this continuous data or discrete data? So, remember that continuous data is where all the numbers in between, all these weird, wacky decimals and all that stuff, if it all makes sense, then it would be continuous data. If it doesn't, if you need exact values, then it would be discrete data. In this case, I have 0 toppings, 1 topping, 2 toppings, 3 toppings. That makes sense. But it doesn't make sense to say, hey, Tony's Pizzeria, I want a 2.5 topping pizza. they won't have a price for that. And even though we can figure out that it should actually be about $11.50, they're not going to do it because they don't do 2.5 topping pizzas, I assume. Anyway, so this is discrete data because exact points are shown. It is not reasonable to have, for example, 3.2 toppings for $12.20. Okay. Oops, I went backwards. What am I doing? Okay, here we go. Come on. Okay, so we have these two graphs here. One of them is discrete. One of them is continuous. You should already understand that part. What you have to do is each of these questions, I want you to think about how you would go ahead and describe these graphs. So let's start with this one here. What does it relate to? We don't have things like the cost and the toppings and all that. So in this case, generally what's going to happen is you're going to say that the y-axis relates to the x-axis because we're watching for every step to the right, we're watching how far up or how far down the y-axis goes. So what does it relate to? Well, it relates to y relates to x. And where does it start? We are all points in quadrant 1. So one thing that you should do, just a very quick review, is remember that quadrant 1 is here, quadrant 2 is here, quadrant 3 is here, and quadrant 4 is here. And yes, it has to be Roman numerals. It has to be. You cannot do 1, 2, 3, 4. No! Don't do that. Okay. So where does it start? I guess I could just say the first point would be right here. It would start at 1, 2. How does it change? Well, it looks like for every 1, 2, 3 steps up, it goes 1, 2, 3, 4 steps right. So 3 over 4. That's my rise over run. I could also that is a simplified form, but I could also say, different numbers too that are equivalent. It would be perfectly fine for you to have pointed out that it goes up 6 for every 8. Because 3 over 4 is the same as 6 over 8. It's just one is more simplified than another. You could also have said 0.75 to 1. Yes, absolutely true. It goes up about 0.75 for 1 over. So we would expect it to be like right here. Okay? Those are all equivalent. They're all the same thing. But it's just a whole lot nicer to have these simplified forms. So I would go with like 3 over 4. All right, and continuous or discrete. This is definitely discrete. Okay, the next one, think about that. Where does it relate to? Where does it start? How it changes? Continuous or discrete data. I have this all written out on the next slide, I believe, so let's just take a look. So graph A, here's what I had. Y-axis relates to x-axis, and the point 1, 2 in quadrant 1 is where it starts. We already talked about all these. 3 to 4, discrete. Now the other one was y relating to x. The line travels through quadrant 1, 3, and 4. That might be tricky for you. You would have to imagine this. Imagine this thing being extended. Oh, I'm really bad at drawing lines today. And, well, every day. Let's try that again. That goes down, and that goes along here. And I'm going to fix this line. Let me get a blue color so it makes sense. So now we got to imagine this line continuing. So that line, if it was straight, it would continue. So we're in quadrant 1, and we are also in quadrant 4, and we are in quadrant 3. So whether you say it starts in quadrant 3, goes to quadrant 4, and then through quadrant 1, or backwards, it doesn't make it either way it works. Just make sure you're saying that it goes in quadrant 1, 4, and quadrant 3. Okay. Let's maximize that again. Okay, moving forward. For every 3 steps up, move 1 step right. And you always want to do like up and right. Look at it like that, rise over run. So let's erase. Wow, what am I doing? Get out of here. Delete. Okay. So pick a nice point that you can isolate. Maybe this one. So this one is a nice point at what looks like 2 and 1. And then we kind of find the next nice point. The next nice point looks like it's right here. So we go 1 step up, 2 step up, 3 steps up, and then 1 step right. So rise 3, run 1. So for every 3 steps up, you move 1 step right. Why do I keep messing that up? All right, and it is definitely continuous because, you know, there's no like individual dots. So that means that all the stuff in between would make sense as well. Okay, now here's where you get a lot of practice. Communicate the ideas. Tell where it's reasonable to have points between the ones on each graph and explain your answer. We have cost and we have distance. So maybe it's like a delivery vehicle or a taxi or something like that. If you are in a taxi and you just travel like 1 centimeter, that's pretty close to 0 kilometers. So you're looking at right here, it's going to cost you $2. All right. If you travel 1 kilometer, it's going to cost you $2 plus, looks like $1 per kilometer. So it moves up $1 for every 1 kilometer that you go at this point. Okay. So the question is it reasonable to have points between the ones on the graph? Well, in this case, I think so. I think you should be able to be charged for half a kilometer distance or 0.9 kilometer. It shouldn't make sense that your taxi has to go exactly 1 kilometer for you to get charged that amount. No, they're not going to do that. That would be a ripoff for them. So what they're going to do is they're going to have a rate, and that rate is going to be calculating along this line where you fall and how much you need to pay. And now in graph B, points between. So this is cost relating to the number of cartons of ice cream. If you go to a store and it's $4 for a carton of ice cream, then it's going to be $8 for 2 cartons of ice cream, $12 for 3 cartons of ice cream. That makes sense. But if you go to the store and say, I want 1 1/3 carton of ice cream, they're not going to open it up for you. So no, that does not make sense to have numbers in between in this case. So what I'm thinking here is graph A should actually be a continuous line and graph B should be discrete. That's what would make sense. Okay. Moving forward. We have about 4 or 5 of these, and like I said, for each of these, I want you to pause the video at this point, look at the graph, look at the information there, try to make sense of what it is, answer all these questions, then unpause for me to just shift over my answers here, and you'll be able to compare your own. So right now, pause your video. I'm going to assume you paused your video. So what is being related? I don't really know what this is really showing. Grounds, cups, coffee maybe? Maybe like how... I don't really know. Grounds and cups. Okay. Whatever it is. But anyway, we have y-axis, which is grounds, and that is related to the cups along the x-axis. Where does the graph start? It starts right here at 0, 0. Is it continuous or discrete? It looks like it's continuous. You can have numbers in between, absolutely. You could have 0.5 cups, and that's going to be whatever grounds it is. So yes, continuous. What is the vertical and horizontal distances between points? You just take some nice points. You got 0, 0 here. You've got 1 and 2.5 there. So for every 2.5 steps up, then you go 1 right. So it would be 2.5 over 1. Quadrant. This is all in quadrant 1. And the slope is positive. I'm just going to write positive, but what you should remember is that your slope is your rise over your run. So my slope is actually 2.5 and it's positive. All right, here's another one. Pause the video and try this one out, then compare your answers. Okay, what is being related? We have distance in meters, and we're comparing it to time. Time doesn't say whether it's minutes, seconds, or what, but whatever it is, it's time. So we have distance, the y-axis, related to time, the x-axis. Where does it start? It looks like it starts at 0, 0. Okay, time of 0, distance of 0. Is it continuous or discrete? It's absolutely continuous. Any point along there makes sense. What is the vertical and horizontal distances between points? So that one, you are trying to figure out how many steps up for every step right. Well, it looks like it starts at 0, 0, and then it looks like it goes to 10, 1. Okay, I could also test it here by putting in 1 for x. So that's 10y. So I have rise of 10, run of 1. It's all in quadrant 1. And the slope is positive. Positive 10, in fact. Pause the video. Try this one out. All right, what is being related? My y-axis is being related to my x-axis. Where does the graph start? That one's a harder one to answer because it goes across multiple quadrants. It doesn't really have a starting place. You could say it starts down here. You could say it starts in quadrant 3 and then goes into quadrant 2 and then into quadrant 1. But just make sure that you are putting that it travels through quadrant 3, 2, and 1. Is it continuous or discrete? Continuous. What is the vertical and horizontal distances between points? So again, find nice points. What I did here is I looked at this one. It looks like it's at x is 0 and y is 1. And then the next nice point is right here at 2 and 2. Okay, so then I look at it and I say, whoops, here we go. How much did it go up? It went up 1 and it went right 2. 1, 2. So rise over run. Rise is 1, run is 2, 1/2. Okay? So that is the vertical and horizontal distance between my points. I could also say 0.5 and 1, or I could say 2 and 4. They all make sense, but 1/2 is a nice simplified form. So we're going with 1/2 here. It's in quadrants 1, 2, and 3, and the slope is positive. Pause and try this one out. What is being related? We have number of visitors and we have months. So the number of visitors per month is what we're really looking at. Where does it start? They don't seem to, if you said 0, 0, you'd be wrong because there's no actual dot there. They didn't really include 0, 0. So it is starting at month 1, and in month 1, they've recorded 150 visitors. So it starts at 150. Is it continuous or discrete? It is a discrete. It doesn't show like a half a month or a third of a month. They don't really care about that. They just care at the end of the month how many people were there that visited. What is the vertical and horizontal distance between the points? For every 150 up, it goes right 1. So 1 month passes and 150 visitors show up. This all happens in quadrant 1, and the slope is positive. Describe the graph. What is being related? Pause the video and unpause when ready. Okay, what is being related? Y is being related to X. Where does it start? What I would say is it's in quadrant 1, it's in quadrant 2, and it's in quadrant... Oh, that's not quadrant 3. That's a mistake. I need to fix that. That's quadrant 4. This is quadrant 3, so that one was wrong. Is it continuous or is it discrete? It is continuous. What is the vertical and horizontal distances between points? So for that one, again, find a nice spot. You could go like here and here and here. Just choose any of those. It's going to be the same any one you choose. So rise over run. Well, it goes down to, I say rise, but rise means up or down, but you're looking at it from left to right. So you pick a point here and see how far it goes down, and then move it right. So it goes down 2, so that's -2, and it goes right 1. So it's actually -2 over 1. And I think I got that right there, -2 over 1, good. Quadrant, hopefully I didn't get that wrong. I did, because I was not thinking. So this is actually quadrant 1, 2, and 4. 1, 2, and 4. And the slope is negative. And you know it's negative because the y value is going down as the x value goes up. And you can see the line going downward from left to right. So that's a negative slope. Okay. I think we're just about at the end. Okay. Pause the video, try this one out. What is being related? We have the y-axis to the x-axis, the cost of the cab ride compared to the distance in kilometers. Where does it start? It starts at 0,4. Is it continuous or discrete? It's continuous. Vertical and horizontal distance between points. It looks like for every one step to the right, we go up 2. So 2 and 1. Quadrant is all in quadrant 1, and the slope is positive. Okay, and I think this is the last one. Yes, it is, the last one. So we have notebooks, not notebooks as in like electronic notebooks, notebooks as in like pencil notebooks, stuff you write in. So cost, $0, $2, $4, $6, $8, compared to the number of notebooks. We're describing the line. So just looking at this in general, what could we say? Well, we could say that it starts at 1 and 2. So the cost of one single notebook is $2. All right, it's definitely discrete data because you're not going to go and buy 1/2 of a notebook or 1 1/2 or 2 1/2. You have to have exact values. What else can we say? We can say that it's all in quadrant 1. We could say it's a positive slope. We could, I've already said quite a bit here. What else? We've done the step. I think we're good. Did I miss anything? Vertical, quadrant, slope. Nope, we got everything. Is it possible to extend this line to 0, 0? So could I put a point at 0, 0? Would it make sense? Yes, that would make sense. You're going to spend $0 on 0 notebooks. It would make absolute sense. Sure, why not? Is it possible to extend this line into quadrant 3? So where is quadrant 3? Remember that if this was my graph, here's quadrant 1, 2, and 3. So we know we can put a dot here. Can we put one here? Can we put one here? Does that make sense in quadrant 3? No. I'm not going to go and buy -1 notebook. I'm not going to go buy -2 notebooks and they're going to give me money. They're not buying notebooks. I'm buying notebooks. This makes no sense. So no, you can't extend into quadrant 3. That would not make sense. Okay, video 1 done. The next ones involve a little more practice, but hopefully you have a good idea of what these graphs are all about and how they relate to each other.